Hi there, this video is going to cover indirect measurement. So what do I mean about indirect measurement? So in the real world, sometimes we cannot directly measure an item. So for example, sometimes I can't directly measure how tall a flagpole is, or I can't measure with a measuring tape how tall a tree in my backyard is. And we can use similar triangles and proportions, which we talked about in our last lesson, to find the lengths of these items. So let me give you a pretend scenario. So in my backyard, there is a tree. And this tree, I'm always afraid, is going to blow over in the wind and crush my house. But the tree is so tall that I can't physically measure. I don't have a tape measure long enough, and I can't even climb the tree to get to the very top branch to see how tall this tree is. So how do I go about measuring it? So one way that I can do that is to use something that I can measure. So for example, let's imagine the sun is shining and I have this tree outside and I measure its shadow and it's 10 feet long. Well, I can measure the 10-foot shadow because that's on the ground. But how does that help me out? Well, let's suppose I'm also there and I also have a shadow. Can I do anything with and comparing my shadow to the tree shadow? Well, you bet. I stand straight up and down. So I form a 90-degree angle with the ground and my shadow, and so does the tree. So I have one congruent angle. Remember, we only need to have two congruent angles in order for triangles to be similar. Now imagine my sun's actually over here shining, and because it creates this shadow. Okay, this angle and this angle on my sun shining down from me is going to be the same because the sun is going to hit us at the exact same degree. So I now have two angles that are the same. Because I have two congruent angles, that by default makes the third one. So now I have three congruent angles, which means my triangles are similar. And just like in our last lesson, if my triangles are similar, then I can use proportions to determine missing lengths. Well, I need to know one more thing, because just knowing that the tree has a 10-foot shadow and I have a 2-foot shadow isn't going to help me. Well, I know that I am 6 feet tall and I have a 2-foot shadow. So I've got this triangle and this unknown triangle. And I'm going to label this down here. And I have these matching sides. So I'm going to write 2 from my small triangle. 10, which matches the side of 10 on my big triangle, is equal to, going back to me because this is me, the bottom is the tree. And on the tree, I don't know how tall the tree is, but I know that I'm 6 feet tall. And I can set up a proportion and solve like I did yesterday. I can cross multiply. 2 times x is 2x. 2 times 10 is 60. And now I just divide by 2. And how tall is that tree? 60 divided by 2 is 30. So that tree is 30 feet tall. And that's how I can use indirect measurement to measure things. All right. So one other thing that I might want to do is calculate the height of a person. Now, usually I can measure how tall a person is, but let's imagine I'm trying to come up with a surprise for my principal, and I need to know how tall they are. And I'm going to try and be a little bit sneakier about it. So what I might do is the principal might be standing there talking to someone else, and I set a mirror a specific distance away from them, and it doesn't matter the distance, but I'm going to measure how far it is, so 2 meters. And then what I do is I back up, walk backwards until I can look down at the mirror and see the top of the principal's head, see from my eyes to the top of the principal's head. Now, Ashton, who's doing this, is 1.3 meters tall, and I'm trying to figure out how tall the principal is? Well, because this angle is the same as this angle, because I'm seeing at congruent angles, and we both stand 90 degrees to the ground, I have two similar triangles because I have two congruent angles. What does that mean? I can set up a proportion. So Ashton's height, Ashton's distance from the mirror, divided by the principal's distance from the mirror, is equal to Ashton's height divided by the principal's height. And I'm going to cross multiply. 1.5p is equal to, what is 1.3 times 2 is 2.6. And how do I solve that the rest of the way? I am going to divide by 1.5 because I have got multiplication going on. 2.6 divided by 1.5, and I have calculated that the principal is 1.73 meters tall. The principal is equal to 1.73, and we're going to round to 2 decimal places, meters tall. So that's another case that I can do. Now, one other case of indirect measurement is measuring across something that I can't measure physically across. So across this little stream, it's too wide for me to walk across, and there's no bridge. So how do I find this distance? Well, if you'll notice this diagram that I have set up, that I have a right angle formed in both of these triangles, and these two angles are vertical angles, so they're equal. So I have two similar triangles, so I can set up a proportion. Now, it's super important when I set up my proportion to make sure that I'm getting matching sides. So if I write down 16 from the small triangle, I need to write down the corresponding side on the large triangle. Now, it's the height of my right triangle, so this is the height of my right triangle, and I'm going to put an X. And then I go back to my small triangle, and I say 18 over, okay, what is that horizontal distance on my big triangle? 42. And now I've got my proportion set, and I can cross multiply. 42 times 16 is 672 is equal to 18x divided by 18 divided by 18, and x is equal to 672 divided by 72 divided by 18, and that gives me a grand total of 37.3. Repeating. We'll round again to 2 decimal places. So 37.33 meters. And without having to walk across a bridge or trample through that stream, okay, I know how wide that is. So this is your turn. So suppose a 6-foot student casts a 17-foot shadow, and a tree nearby casts a 102-foot shadow. Find the height of a tree. And again, pause the video, try this on your own, and then let's solve this together. So 6. All right, so let's go ahead and try this. 6 is the height of me. H is the height of the tree, equals 17 is the height of the student, 102 is the shadow. So we're going to multiply 6 times 102, 612 equals 17h divided by 17. 612 divided by 17 is 36. So the height is equal to 36. All right. If you have any questions, please reach out to your teacher and have a great day.